And we are back with the peripheral nervous system, which is the other antagonistic nervous system to the CNS. Whatever the CNS doesn't do, the PNS takes its sloppy seconds up, basically. So, like before, we're going to start with the glial cells. So its main glial cells, that's the last time I used that big of a pen because we need to save space. There's only two of them, actually. They're going to be, and this was actually a question on the last quiz, so you better know this one specifically. The two PNS cells are Schwann cells and satellite cells. Schwann cells being, they make up the myelin sheath, and then the satellite cells, they basically provide structural support and they regulate the microenvironment. So before we even get into the major structures, there's just a couple things we have to go over in the beginning that will help us make sense of the rest of it later on. So in the PNS, myelin is actually formed, like I said before, by Schwann cells. And whenever the myelin wraps around, the axons and sheathes them, the myelin actually leaves gaps. And this process of the myelin wrapping itself around the axon and sheathing it is called myelination. And these gaps that it leaves, the gaps are actually the nodes of Ranvier. Nodes of Ranvier. And another random esoteric topic that we're just going to quickly go over, which I don't think is really that big of a deal or is going to be that big of a deal, is neuroplasticity. Basically, it's your body repairing boo-boos, but for your brain with neurons. So, specifically in the CNS, if you incur damage to parts of the CNS, it's really, really hard to repair that because it's so specialized and it's so intricate. It's like shattering a china dish. You shatter it, there's legitimately no shot that you're gonna be able to completely repair it, like back to its 100% structural integrity. Whereas in the PNS, the cells actually can recover damaged synapses. However, they might have gotten damaged. It's not really our concern. We don't get paid enough to care about that. But they can damage synapses. They can repair and recover damaged synapses if the cell body itself is not damaged. And that's key. You damage that cell body, that's a no deal, my friend. It's not going to happen. You got to look elsewhere. And in this process, there is a name for a certain process that goes on, and it's called chromatolysis. Now, chromatolysis is the dissolution of the Nissl bodies and the reformation of the axon and synapse, which is that recovery we were talking about, by the cell body. Now you see why the cell body can't be damaged, because if it's damaged, no chromatolysis. That's a no deal. And the cell body and the surrounding glial cells. Now, quick crash course onto the parts of the PNS, the peripheral nervous system, because in this specific nervous system, there's actually sub-nervous systems. So the PNS actually splits up into other nervous systems. So you've actually got the PNS, which breaks down into the autonomic nervous system, and then that breaks down into the sympathetic nervous system, the parasympathetic nervous system, and the enteric nervous system. Sympathetic nervous system, fight or flight. So, if you get mugged and you feel like you're wired, that's your sympathetic nervous system absolutely blasting norepinephrine and epinephrine into your system. When you reach safety and you finally get that 911 call and the cop shows up and saves your ass and you can finally rest, that is the parasympathetic nervous system bringing you back to a chilling state. So you're like, no, like I'm good to go. Like the cops are here. I'm safe. And you know how when you eat food, do you think about digesting the food? Like, do you think, I'm making a conscious effort to move the food through my duodenum and make it get through my intestines and whatnot? No, you're not. So that's part of the autonomic nervous system. Guess what the autonomic part stands for? And the specific portion of it that controls your bowel movement and, your gastrointestinal processes is going to be your enteric nervous system. So we're just going to say GI. Gastrointestinal, not GI Joe. Get it together. GI processes. Okay. So we're actually going to go ahead and highlight this real quick because there's going to be a lot of branches that come off of this. The rest of this space is going to be filled with just PNS stuff, I swear. So, just basic origin story. You know how Batman became Batman because his parents died? Well, the PNS is made of two kinds of neurons. That's its origin story. It's got the motor neurons and sensory neurons. Take a wild guess as to what those two do. I'm not going to answer that for you. You should know. Now, the nerves and ganglia are typically housed, it's put in parentheses, mostly outside of the brain, and we're going to abbreviate the spinal cord as SC because, again, I'm extremely lazy and unmotivated. Like I said, it's basically mopping up the sloppy seconds of the CNS, and that's why it's chilling outside the brain and the spinal cord, because those are some of the main components of the central nervous system. That's why I said it is the CEO of mopping up sloppy seconds. So coming down into the PNS, the ganglia are a pretty important part of the PNS. I mean, they typically are important in general in any nervous system, but in here there's a lot of stuff that the ganglia does specifically. Now, the ganglia is obviously made of ovoid bodies. Obviously, as if that's an obvious thing. I guess that's general knowledge. We're med students now. Who knows? And the ganglia, specifically in the peripheral nervous system, is the relay center. So if you watch Breaking Bad, you know that dude who crashes all those airplanes because his daughter died and kills all those people? Yeah, this is where he'd be working. So you don't want him to crash your peripheral nervous system. That would not be good. So the relay centers are actually very, very significant, just like that dude's job in Breaking Bad was with that plane conducting. They're very significant because the direction of impulse actually determines the type of ganglia present. Well, that could go two ways, partner. Way number one would be your dorsal / sensory ganglia. Now, the effect that this has is it goes from effector organ to, I don't know why I'm spending so much time on that error. It was just bothering me. I have OCD. Effector organ to the ganglia. And again, since it's sensory, it's typically involved in input, and that input is going to be sent to the big boys up at the CNS for processing. The rest is a little bit above their pay grade, so they don't really mess with it, you know what I'm saying? Now, the other portion of it, you know, if this was an input, as was very similar with the CNS, what would the other portion be? It would be the autonomic or motor-based. Now this one, lo and behold, you know, this might be a huge shock to you, but this one travels impulse-wise from ganglia to, wait for it, effector organ. Crazy stuff. Now, this process, you know, these both kind of staying in antagonistic processes to one another, this, you know, as the body likes to do, this maintains homeostasis. Now, in the autonomic portion of the ganglia, there are two neurons that are significant in the chain that it exhibits. So the first neuron in the chain is going to be termed as pre-ganglionic. While the second, I don't know what that was. While the second neuron in chain is going to be, take a wild guess, post-ganglionic. Now, in the second neuron in the chain, the one that's post-ganglionic, this one, as well as the first neuron in the chain as well, these both, their functions actually get split up in between the sympathetic nervous system and the parasympathetic nervous system. So the cell bodies in the sympathetic nervous system, specifically for the neuron chain, the preganglionic and postganglionic interactions, are going to be housed in the thoracic and lumbar segments of the spinal column. And this portion actually, and I'll detail it later at the end of me writing it all down, is going to be the interaction of the first neuron. Now, going down this arrow that I just have underneath what I wrote in orange, that is going to be the second neuron's interaction, where it's housed on small ganglia along the spinal cord. Now, on the other end, in the parasympathetic nervous system, the cell bodies are housed. That's way too far from that, and I don't know, that stresses me out. Are housed in the medulla, the midbrain. And the sacral parts of the spinal cord. Now again, coming down with the arrow to the second neuron interactions. The second neuron it is housed and having most of its processes on the small ganglia near the effector organs. Now, I told you I was going to label it. These two interactions, first neuron. These two, second neuron. Now I'm going to try and move these up a little bit because we have some interesting stuff to go over in this bottom section. Now, the nerve fibers in the PNS, and this was also actually a question on the quiz. It was the one that we didn't end up going over. The one that she took off, the one that, Puria and I got right because we're goated individuals. Shout out Puria, my boy. The organization of this is, as I'm sure you looked up after the quiz in anger, you've got the endoneurium, the perineurium, and the epineurium. Now, a good way to identify their place is by their prefix, pre as in the beginning portion of the word. So a lot of these medical terminologies come from Latin, and as we've seen with other structures in histology and anatomy, endo is going to mean inner, endo, and epi, kind of like the epidermis, is going to mean outer. So we are starting from the inner to the outer portions of the PNS nerve fiber organization. Now, these layers all serve unique purposes. So the endoneurium, it covers a single axon, just one, no more. It doesn't get paid enough to do that, you know what I'm saying? It has other shit to do. The perineurium covers bundled axons or fascicles. The epineurium, it wants all the smoke, so it covers multiple fascicles. That is the organization of the nerve fibers. Now, going back to the PNS with the Schwann cells and its myelin sheath that it forms. Now, myelination itself is actually very significant in nerve fibers because it regulates a couple of its characteristics. So you've got unmyelinated nerve fibers and myelinated nerve fibers. So if you start off with unmyelinated nerve fibers, we're just going to talk about that portion right here. You know, it's not sheathed, okay? It's, you know, a sheath is going to add a little bit of girth to it, but, you know, it ain't got no sheath, so it's not going to have as many layers. Whereas, ooh, when you throw some myelination in there, you got these myelinated nerve fibers, man. Oh my God. Now you're talking multiple layers of lipids, which is the joining of the Schwann cells. Now, this myelination is only in portions of the axon, not the whole length. Ooh, cut it a little too close there. Now, this process of its myelination and the electrical impulse getting sent along this border is known as saltatory conduction. And what that simply is, it's actually, it sounds ridiculous, but it's actually not as complicated as you think it would be. So basically, saltatory conduction is just rapid signal or, you know, impulse transmission along the I'm going to abbreviate this because we're running out of space. Nodes of Ranviers. So it jumps from one node of Ranvier to the next, and it just keeps doing that. Now, if you remember your biochemistry, the myelinated sheaths being made of lipids, you know, fatty acids, lipids are extremely hydrophobic. So they prevent any action potentials from propagating anywhere else besides the nodes of Ranvier. And this kind of keeps it in check and keeps it from just going all haywire in random directions. When it comes to saltatory conduction, it specifically and only travels in a rapid transmission along nodes of Ranvier. So from nodes of Ranvier to nodes of Ranvier. So we could just say that the myelination prevents transmission other than NOV to NOV. And that, my friends, is the peripheral nervous system. Yeah, it's a lot, but I don't think they need us to understand it. I think they just need us to regurgitate it. So I think if we just, go over these things, we'll be fine, and we'll get the points, and we'll make it to the final.